Mitochondria, often referred to as the powerhouses of the cell, are at the very heart of energy production in the human body. These tiny, double-membraned organelles generate adenosine triphosphate, ADP, the molecular fuel that powers every physiological function, from muscle contraction to neural signaling to immune defense. But mitochondria do more than just supply energy. They also regulate cellular metabolism, oxidative stress, apoptosis, programmed cell death, and even inflammatory responses. As such, their health is directly tied to the aging process. When mitochondrial function declines, the entire body suffers, manifesting as fatigue, slower metabolism, cognitive impairment, and increased vulnerability to chronic disease. Emerging science is now focused on preserving and enhancing mitochondrial health as a key strategy for extending both lifespan and health span. One of the clearest patterns observed in aging biology is the steady decline in mitochondrial efficiency. With age, mitochondria produce less ADP, generate more reactive oxygen species, ROS, and become less capable of repairing their own damage. This not only reduces cellular energy output, but also increases oxidative stress, a major contributor to DNA damage, tissue degeneration, and chronic inflammation. The result is a self-perpetuating cycle where damaged mitochondria produce more ROS, which in turn causes further mitochondrial damage. Over time, this contributes to sarcopenia, muscle loss, neurodegeneration, weakened immunity, and cardiovascular decline. The brain is particularly vulnerable to mitochondrial dysfunction. As one of the most energy-demanding organs in the body, the brain relies heavily on mitochondrial performance for memory formation, learning, and mood regulation. It's no coincidence that many neurodegenerative diseases, such as Alzheimer's and Parkinson's, show early signs of mitochondrial breakdown. Fatigue, both physical and mental, is often one of the first symptoms of mitochondrial decline. Likewise, metabolic disorders like type 2 diabetes and obesity are closely linked to impaired mitochondrial biogenesis and function. Fortunately, this decline is not irreversible. Mitochondria are dynamic. They grow, divide, and can be recycled through a process known as mitophagy, where damaged mitochondria are selectively broken down and replaced. This means they can be repaired, renewed, and even regenerated, especially with targeted interventions that stimulate mitochondrial biogenesis and protect against oxidative damage. Several lifestyle and nutritional strategies have shown strong potential in supporting mitochondrial health. Regular physical activity is perhaps the most powerful natural stimulus for mitochondrial renewal. Endurance exercise, in particular, promotes mitochondrial biogenesis in muscle and brain tissue by activating key signaling pathways like PGC, 1A, EMPK, and SIRT1. These same pathways are also engaged by caloric restriction and intermittent fasting, which mimic nutrient scarcity and push the body toward greater energy efficiency and repair. Nutritionally, specific compounds have shown promise in enhancing mitochondrial performance. Coenzyme Q10, CoQ10, an essential component of the electron transport chain, is frequently depleted with age. Supplementation has been linked to improvements in energy metabolism, cardiovascular health, and even reduced symptoms in patients with neurodegenerative conditions. Likewise, PQQ, pyrroloquinoline quinone, a redox cofactor found in trace amounts in certain foods, has been shown to stimulate mitochondrial biogenesis and reduce inflammation. Another class of promising interventions includes NAD+ precursors like NMN, nicotinamide mononucleotide, and NR, nicotinamide riboside. NAD+ is a critical coenzyme required for energy metabolism and DNA repair, and its levels drop significantly with age. Boosting NAD+ not only enhances mitochondrial function but also activates sirtuins, enzymes involved in longevity, stress resistance, and gene regulation. Animal studies have shown that NAD+ restoration can reverse some aspects of aging, improve muscle strength, and extend lifespan. Other natural compounds like alpha-lipoic acid, acetyl-L-carnitine, and resveratrol support mitochondrial health by improving fat metabolism, protecting against oxidative stress, and promoting mitochondrial turnover. Even common dietary elements such as magnesium, B vitamins, and omega-3 fatty acids play essential roles in mitochondrial enzyme function and membrane integrity. Beyond supplements, sleep is an often underestimated ally in mitochondrial repair. Deep, restorative sleep allows for the removal of damaged cellular components and the replenishment of antioxidant systems. Conversely, chronic sleep deprivation impairs mitochondrial function, increases oxidative stress, and accelerates aging on a cellular level. While much of the research into mitochondrial rejuvenation is still emerging, what's already clear is that mitochondria are far more than background engines in our cells. They are central regulators of life, death, and aging. Their decline contributes not only to the feeling of getting older, but to the onset of virtually every major chronic illness associated with age. Investing in mitochondrial health is therefore not about chasing youth. It's about sustaining energy, clarity, and resilience throughout the aging process. Whether through movement, targeted nutrients, fasting strategies, or sleep optimization, supporting mitochondrial function offers one of the most direct and effective pathways to slowing biological aging. As science advances, mitochondria are no longer viewed as passive victims of time, but as active participants in the quest for longevity. The better we understand and care for them, the more powerfully we can influence how we age.